most challenging large optics ever made. So that's why we're here at this special facility. The Giant Magellan Telescope it's our aspiration to build the next great astronomical observatory, the world's largest telescope. So the goal is to make a single coherent optical surface. We'd like to make a 25-meter mirror. So if we knew how to make one mirror, 25 meters in diameter, and then get it to the mountaintop, that's what we would do. But we can't, so we cut it up into small pieces, and 6 of those 7 mirrors are off the axis of symmetry of this 25-meter diameter parent surface. In order to make these off-axis optics, the first thing is you have to cast them into the right shape. So what happens here at the U of A is first they build a furnace, which we will melt the glass. Then they build a mold that will give us this mostly empty honeycomb shape. We melt all the glass, we spin the furnace, we then cool the glass to freeze in this shape. You have to carefully cool it for a few months to anneal out the stresses. When the mirror is cooled, it's this sort of 20-ton piece of glass, but inside it, it's got another roughly 20 tons of mold material and the silicon carbide bolts and tiles that held it to the ground. They lift it up, they move it over, and then they turn it so now it's hanging vertically. So now you've got this 40 tons of glass and mold material hanging on this frame. And the first thing they want to do is get all that mold material out of there just to lighten the glass. So they go from 40 tons to 20 tons in just a couple of weeks. Then this same lifting fixture is turned face down, and the mirror will sit on that for the next year while we machine the back surface flat, polish it to make sure it's structurally solid. Then there's a long process of processing the blank until we're ready to start polishing the front surface. And it's very difficult to polish because it's a long way from a sphere. So there's a lot of clever optical engineering that went into using fold mirrors and redirection of the beam so we could do an on-axis test for an off-axis mirror. And that final polishing process to get that precise optical shape that differs from a sphere, that takes about 18 months. That'll get us down to nanometer level precision. And then in 2023, we should have the telescope on its concrete pier inside the rotating 22-story building. We'll put those mirrors in the telescope. We'll start to look at the stars for the first time.